Sir, is my slide visible, sir? Hello?
Yeah, yet to
Is
be,
it
ma'am.
visible?
Now it's visible. Yes, yes, yes.
Okay. So, first of all, I would like to thank the organizers for having given me the wonderful opportunity to be a part of Atal FTP, organized by Sri Krishna College of Technology, Coimbatore. And now I'm much privileged to deliver a lecture on Introduction to Industry 4.0 and Industry 5.0. So, and once again, I would like to thank the for having given the nice introduction about myself. So now let me go my pages of PPT presentation. So let me start with a video regarding industrial revolution. So and then we will move on to industry 4.0 and 5.0. Again. This video illustrates where we are, what is the position. It is a part of industrial revolution. So starting from industry 1.0 to now we are at industry 5.0. This YouTube video clearly tells about industrial revolution.
Sir, Swamiji.
ഇതെന്നിട്ട് എനിക്ക് അത് ക്ലീൻ ചെയ്തിട്ട് ഞാൻ കുളിക്കട്ടെ കുളിക്കാം.
Okay, it makes a delay. So let me go my presentation. So I will share the link, then you can witness afterwards. Okay. So this slide shows an animated video about industry Sir, is it visible to you? Anyone can respond, please.
Ma'am, it's
Hello?
flickering.
Am I
Hello?
audible?
Yeah,
Sir?
audible, ma'am, but the screen is
Am I
not
audible?
visible.
Sir, are you shared now?
Yeah, now it's visible, ma'am.
Okay, okay, sir. Okay, this is an animated video of industrial automation. See, there is a conveyor over which a box consisting of various objects of different colors are moving.
Ma'am,
Okay, and there is a computerized screen. Sir,
the screen is
hello?
not visible, ma'am. The video which you are, it's not visible. Now it's visible, ma'am. When you go to full screen, it's not visible.
Now, sir?
Yeah, ma'am. It's visible. Screen
Okay,
is visible, ma'am.
okay. Okay, sir. Thank you. So, see, this is an industrial automation animated video. So, here from the conveyor, a box consisting of various colored objects are moving, and there is a screen which shows identified colors. So, based upon the desired color, what we need, then the money has been generated. So this much actually without this one, manual sorting is to be carried out by human being, but now it can be automated. So by manual sorting, the task is a tedious one. It is not easy to resolve. But whereas computerized automation can do the sorting easily, and how many number of the desired colored objects are moving, based upon that there will be a trending, there will be a chart by which the money has been generated. Everything can be depicted by this video itself. This is an industrial automation, but let us go with the evolution. So starting with industry 1.0. From this animated video, a person is putting that is there is a hammer which hits the object. Okay, the man is holding that knife, and which has been sharpened by means of hitting by the hammer continuously. So manual, but the automation, the hitting of the hitting by the hammer can be done. Okay, there is a bellow, so by been done. So this is a semi-automatic one. In the earlier days, under Industry 1.0 revolution, this is the first one. And whereas this picture shows there are two persons are standing. Okay, right? Cars are moving, and one person is checking the tires, and another person is doing the painting of the car. So, Industry 2.0 here, there are two persons are standing. It does not mean for Industry 1.0 one person, for Industry 2.0 two person. Okay, so here there will be two parallel works have been done. So, that is the meaning behind Industry 2.0. So let us watch the animated video. After that, we will go with the statements, right? So coming to Industry 3.0, there is a person. So we all know there are operator workstation and engineering workstation. So here the person who is an operator, who is an engineer, sitting in his control panel. So in front of that particular engineer, there is a panel. So by which he is automating. So here there is a robotic arm. That robotic arm can be picking and placing the electronic objects, okay, like transistor or diode or diac or triac. So depending upon the circuit in which what we try to do the assembly of the electronic components, okay. So that can be automated by the person who is sitting over the panel, okay. So this is an industry automation. So he can able to operate a robotic arm which will do the operations what we desired to have. Coming to industry 4.0. So there are two robotic arms, but only one person. So see, this is a familiar symbol, what we know. Okay, there is a Bluetooth. So this shows remote transmission. So so and over which there are some cloud. Okay, so which means the data can be communicated by means of cloud. So we can able to store the data and we can able to retrieve the data. So here two robots are operated parallelly by means of command given by a single operator. This is industry 4.0. So coming to the statement, okay, industrial revolution. So starting from the year between 1760 to 1820 and 1840, there was a transition happened regarding new manufacturing process. This transition included from hand production methods to machines. In the earlier days, manually the persons are doing manufacturing, maybe a matchbox or any other smaller tools, everything and all, okay. So minute particles, they were unable to get the machines at that time. They have tried to manufacture by their own. So after a certain period there was a transition. So that production started from that is handed over from a man made to machine made. So, and it was introduced in chemical manufacturing and iron production process. And after that, there is an increasing use of steam power and water power. So here, the steam power is the main thing. Okay, the automation, the industrial revolution started with the automobiles. First, the industrial revolution has been started in the automobiles, the two steam engine. Okay, the development of the machine tools and the rise of power mechanized factory system. So as I mentioned, industrial revolution began in 18th century, and when the agricultural societies became more industrialized and urban. So this has been moved to railroad, then cotton gin, and then electricity and other inventions have started using the industrial revolution. As what we have seen the animated video industry 1.0. So the evolution of industry starting from 1.0 to 5.0 now. So here I would like to mention 1.0 to 5.0. Okay, industry 1.0. So there were mechanical production facilities introduced in 18th century, that too paving the way for steam powered machines in order to help the workers for the field of manufacturing. Okay, so from the concept of industry 1.0 is the starting version of the industrial revolution. So see the mechanized work. So the lady is doing the mechanized job. So it all began with the first industrial revolution. Industry 1.0 is the first industrial revolution. It has been referred by industrial revolution. The name industrial revolution has been called by means of industry 1.0, and manpower to machine power, and there are certain fuel resources like steam and coal made machine use are noticeable in the industry 1.0. And as the people who were used the industry 1.0, they have spread the usage of the or the applications of the industry 1.0, and everyone started to prefer the industrial revolution. So machines are allowed faster and easier production. Productivity has been improved, and there were faster response. So that's why they made all kinds of new innovations and technologies as a possible one. And coming to Industry 2.0, so it is called as technological revolution. So this technological revolution is identified during the period 1760s and around 1840. And historians somewhere refer to this as technological revolution, where superior electric technology allowed even greater production and more sophisticated machines. So here completely transformation has happened from man-made to machine-made. And coming to Industry 3.0, Industry 3.0 was centralized around advances in the electronics. So even though we have been preferred with machine-made operations for manufacturing, somewhere electronical appliances have been introduced. So electronical technology have been applicable in the Industry 3.0, especially in the decade of 20th century. So the automation of machines and introduction of the advanced software systems has evolved over the years as advancements. It is called as historians called Industry 3.0 as digital revolution. So each and every version of industrial revolution has been called with a specific name. So for Industry 3.0, the specific name is digital revolution, because everything is digitalized. So digital revolution began with the first computers. So we all know computers play a major role in our day-to-day life. So for our easy work life, for recording, for storing, data logging, everything, computers have been played a major role. So incredibly larger usage of computing and computing power they were able to provide. But they laid the groundwork for the world today, and it is hard pressed to imagine without computer technology. So no one can imagine nowadays without computer technology. So third industrial revolution, especially during the year 1969 onwards, a big industrial revolution that is called digital revolution was made. Now coming to Industry 4.0. Industry 4.0, it is a concept introduced in the year 1990s. So here cloud computing has been introduced, and for which we preferred internet and communication, remote communication. Okay, so internet and telecommunications transformed the way we connected and exchanged the information. Whatever we would like to communicate, everything was possible. So this technology merged the boundaries of the physical and virtual world further to manufacturing. Not only in manufacturing, they were introduced newer technologies into the industry as a reality. So, proponents of Industry 4.0 refer to the concept in terms of a smart home. That is, we can able to create a network of smart factories. So, and there were such as there are several capabilities, digital capabilities like sensing, scanning, programming, programming with more memory, voice, and facial recognition. Everything was possible. So here, the Industry 4.0 technological pillars are illustrated in this picture. So advanced robotics. Robotics will do pick up and place up the objects, whether in a box or traveled through a conveyor. And then 3D printing. 3D printing can be used to imagine what kind of object to be used. And then machine to machine communication. Nowadays, machine can able to communicate with machine, and then it is easy to communicate and easy to use mobile technologies, and the data, wide range of data has been communicated in the cloud, and then cognitive computing, and then it uses human memory, and then technologies and Internet of Things, and then big data analytics. Wider level data has been used. So for all these things, the crown based technology is cyber security, because we all would like to believe whether the industry 4.0 is a secured one. Yes, of course, cyber secured is an ensured one when we prefer the industry 4.0. It is a concept related to fourth industrial revolution, which is 4IR. It is associated with the advancements of cyber physical system. Hope many of you might have used a cyber physical system. So it describes the rise of automated systems and data exchange technology within manufacturing industries. There are several examples, the important examples of the industry 4.0. I would like to point out three things. One is IoT, that is Internet of Things, and second one is industrial IoT, that is IIoT, and third one AI, artificial intelligence. So what is cyber physical system? Cyber physical system, it is a mechanical device that is run by computer based algorithms, because we are talking about industrial operations. So we all know in industries there are huge bulkier machines are in use. So for by which that mechanically operatable devices have been operated by means of computerized algorithms. Okay, that is termed as cyber physical system. And IoT, Internet of Things, which means that interconnection of the machine devices and the vehicles which are embedded with computerized sensing. So machines have been embedded with computers. So that is called Internet of Things. So which include computerized sensing, scanning, and monitoring facilities. So we can connect various number of appropriate sensors which can do their job of sensing the physical quantities wherever we would like to monitor. First one is sensing. So appropriate sensors are to be used. Once the sensors have sensed the physical quantity, that data has to be scanned or stored, and the monitoring capabilities have been improved. And cloud computing, it is an offsite network hosting, and it can be used mainly for data backup. So without cloud computing, it is not possible to imagine how much amount of the data can be stored in a computer or a hard disk. Okay, so with the cloud computing, we can store wider range of the data. Okay, and the next one is cognitive computing. So human based intelligence, decision making with artificial intelligence. So that is called cognitive computing. So somewhat the decision making has been carried out with intelligence. So that is called cognitive computing. So these all cyber physical system, IoT, cloud computing, cognitive computing, these are all the basic elements of industry 4.0. So without anyone among all these four, we cannot have the industry 4.0 as a possible one. And what are all the key concepts of industry 4.0? We can call industry 4.0 is a paradigm of connecting various kinds of physical devices, that too depending upon the type of the application. We cannot use same kind of sensors for all types of the process. So depending upon the type of the manufacturing industry or type of the process, we have to embed physical devices. Okay, and they can able to interact. The communication among the physical devices is possible. They can able to interact man to machine. Man to man is possible, and man to machine is possible. Now my machine to machine is also possible, and this can be facilitated by IT enabled customization in manufacturing. That is the main concept of the industry 4.0. Transformation of the manufacturing process with the help of IoT platform into cyber physical systems, or adaptable one, increasingly adaptable. Everyone wanted to adapt this kind of digitalized platform, cyber physical system based platform. Okay, so this has been introduced as per demand driven, and every industries put a demand for using the industry 4.0. So that's why there is a possibility to allow for customized and personalized high quality products. And here for Industry 4.0 production, it is very important to implement both horizontal as well as vertical integration of the value network and the production inside any kind of the factory. And Industry 4.0, here we can have four things. One is our means what are all the smart products, what are all the sensors to be interconnected, sensors to be connected as a network. Okay, so there should be a sensor technology or which has to be given an access for uh, product and its environment monitoring. There should be awareness. First one. Second one, connected. So all these things. Next one, we can show the intelligence. Smart products are equipped with the computing power that enables autonomous decision making and self-learning process. So once we interconnected the suitable or appropriate sensors or smart sensors or smart products along with the computing facility, there is a possibility of providing intelligent decision making. There is no need to interfere with the man. Okay, so machine to machine communication, and whatever the decision should be taken, everything is taken as an autonomous decision. And that's why it can be done by self-learning process. And then responsive smart products are equipped with the control technology enables autonomous product adoption based on and external commands. So as per the commands, as per the desire, the requirements, then a responsive communication is to be carried out. We have to put a request, and as per the request, there should be an acknowledgement. Based upon that, response can be made. So, by which smart products are equipped with to machine communication device, it enables interaction and data exchange with other cyber physical systems. So not only between a single one, we can able to have a communication among various smart sensors which are interconnected into a system. So this shows the clear picture of the Industry 4.0. And Industry 4.0 technologies, as I already mentioned, Internet of Things, big data analytics, cloud computing, simulation and prototype, 3D printing, augmented reality, virtual reality, and robotic systems. And there is a process integration. All these things have been integrated or interconnected in order to ensure human to machine collaboration. There should be a communication between the man to machine collaboration as well as shop floor to equipment integration, machine to machine integration. So the sustainable outcomes with respect to Industry 4.0, we can able to improve the economical considerations, and we can able to automate the process with the safety, and the environment to be protected. So there is an assured protection of the environment. So cyber security is the key factor for following the Industry 4.0. Then coming to Industry 4.0 principles, there are 6 key principles. One is interoperability, and second one is virtualization, third one is a real-time capability, and the fourth one is decentralization, and fifth one is modularity, and the last one is service orientation. So this entire picture depicts sustainable Industry 4.0 environment along with key principles of Industry 4.0. Let us see in detail. So first one is interoperability. So from the name itself, we can able to understand it is a proprietary vendor. The ability of the cyber physical system as well as the humans or smart factories to connect and communicate with each other. So there should be operation between all the sensors which are interconnected. Okay, so there should be operation internal to all the devices. That's why it is called as interoperability. So connection of CPS, people and various manufacturing systems, and there should be a good collaboration between machine and man, and then there will be information technology and operational technology convergence, IT and OT convergence, and there should be reliance between IoT and the people, and various standards and protocols and the connected data. Everything can be coming under interoperability. And next one is virtualization, because there should be virtual reality and augmented reality. So with respect to IoT, we have to first virtually depict the situation. So visualization, it provides a virtual copy of the smart factory. What should be the factory layout? What should be the position of the sensors, various sensors, how they can be interconnected, everything linking by various sensors with the tag name, everything should be coming under the design principle of virtualization. So there should be virtual representations and copies, and sensor data and contextual data, context aware information, digital manufacturing and plan models, and simulation models and digital twins. So all are coming under virtualization. So we have to first identify the layout of the smart factory along with positioning of various sensors which need to be integrated. Then only we can able to get a desired requirements, our requirements to be fulfilled. Third one is decentralization. So hope you all know decentralization. So suppose if it is centralization, the decision will be with only one. But whereas decentralization means there will be the ability of CPS within the smart factories to make decisions on their own. Autonomous and semi-autonomous decisions can be made, and intelligence towards the edge level, and the cyber physical system as a decision maker, and the human to machine element in planning as well as decision making, and the ubiquitous decentralization from manufacturing to warehousing and logistics. So decentralization not only in only one side, it can be spread over the entire smart home. Okay. And the fourth one, a real-time capability. This is also very important, because once we decided what to use, which sensors to be used, so after having picked up the suitable sensors, we have to do interconnection of the sensors. We can have integrated assembly of various sensors. So after, what is the next step? We have to get the acquisition. We have to collect the data. So capability of the data collection as well as analyzing the data what we collected, and finally we need to provide the insights immediately. So real-time data for real-time economy, and immediate collection and analysis to obtain desired insights. Suppose if it is not up to the desired mark, we have to change the sensor and we have to change the data logging accordingly. And then fast data for flexibility, and then focus on decisions and preventive as well as predictive maintenance. And next one, service orientation. So offering Industry 4.0 offers various services via Internet of Things. In IoT, Internet usage is very essential. So cyber physical system supporting various kinds of people at various places as a service economy, and personalization and value added with focus on customer based upon the demand driven. And then Internet of services is very important, and we can able to provide various services by introducing new service models. And the last one, modularity. Yes, scalability, and then we can expandability, everything comes under modularity. So here flexible adaptation of the smart factories for changing the requirements of individual modules. So here we can have a module, maybe a smaller level to larger level. Okay, depending upon our usage, we can able to introduce various modules. Whenever it is not in use, we can able to replace the module. So attachment as well as detachment of various modules are possible. So replacement as well as expansion of the individual models as per the demand, as per the response of changing needs, then we can able to do. And then customer centricity as per the customer requirements, then we can do. And flexibility and agility is possible. And then planning for the unpredictable. Okay, so what will be happened in future? So it is, if it is challenging one, if it is not possible to predict, then we can use the industry 4.0. And then it can be applicable in the dynamic environment. How it can be used, industry 4.0 used in manufacturing. Here I am not dealing all these things in detail, just I will tell the title, because I need to go with industry 5.0. So supply chain management, so these are all well known one. So after smart manufacturing, supply chain management is important, then only we can have a continuous supply of the products as per the demand from the people. And then predictive maintenance. So predictive maintenance is very important in order to reduce the downtime or failure time. So maintenance is very important. And then tracking and optimization. We need to track the inventory starting from the base level to top level. We need to do the tracking, and then only we can able to provide the optimized performance. Standard asset management task like asset transfer, disposal, and then certain reclassification, adjustment, everything can be possible and it can be done in real time. Okay, so industry 1.0, in simple word, mechanization, which can be done with the steam power. The best example is weaving loom. And the second one is industry 2.0. It can be invented mainly for mass production. It was first dealt in assembly line, which used electrical energy, steam engines. Steam engine to train. And then third one, industry 3.0, which has been carried out with computerized thing. And there were introduction about the electronic components. So automation carried out with computers as well as electronics. And industry 4.0, which dealt cyber physical system and internet of things and various networks. So I have mentioned with the name of PLC. PLC, we all know it is an automation hardware which has been introduced in between industry 3.0 and industry 4.0. So let us see what is the role of industry 5.0. So wait for the coming slides, industry 5.0. And I hope we can skip. Okay, coming to industry 5.0. So industry 5.0, it is a personalizable revolution, that HUB revolution. So human machine interface. So it was simply a SCADA software. So whatever the operation carried out at the plant level, we can simply relaxedly, we can sit in our computer room itself and we can able to monitor. Not only monitoring, we can able to control. Everything is possible in the industry 5.0. It means that industry 5.0 term refers to people who are working alongside robots and smart machines, and they can sit in their room and they can able to operate robots as well smart machines. It's about robots helping humans who work better and faster by adapting advanced technologies like big data analytics as well as internet of things as well as industrial internet of things. Okay, so that is the more advanced technology behind industry 5.0, and it adds a personal touch to the industry 4.0 pillars: automation and efficiency. So industry 5.0 refers to people who are working alongside robots and smart machines. Okay, so see, once again it shows water and steam production, power, and then mass production and assembly line, and as a third one, electronics and automation, fourth one physical system, last one personalizable autonomous manufacturing. This is the industry 5.0. This picture depicts the industry 5.0. So once again, this is the revolution 1780 mechanization. So industrial production was based on machines powered by water and steam, so only mechanical operations. And during 1870, electrification, so man-made to certain machine-made has come in order to improve the mass production. And the 1970 onwards, automation started, and 1980s globalization. So shows better production in the offshoring of production to lower cost economics with reduced cost with and increased production. So that shows the globalization. So because it was carried out between 3.0 and 4.0 revolution, that's why it is mentioned that industry 3.5 revolution. And industry 4.0, as I already mentioned, it is a digitalized one. So introduction of the connected devices, data analytics, and artificial intelligence technologies. And then last one, industry 5.0, it is a future. Nowadays, everybody is depending on industry 5.0. It is a fifth industrial revolution, or it was completely focused on cooperation between man and machine, as human intelligence works on harmony with cognitive computing. So as I already mentioned that it it completely relies on the artificial intelligence. So by putting humans back into industrial production with the collaborative robots, workers will be upskilled in order to provide very much valuable task in production, leading to mass customization and personalization for customers. So whoever asking any demand, whoever putting the demand, as per the demand driven, so personalized customization has been carried out with the industry 5.0. Whatever demand, then it will be resolved. So this is 18th century. Second one is 20th century. From 1917 onwards, third revolution, and 20th century. 2000 onwards, fourth revolution. Nowadays, it is emerging. So once again, the last one, after automate cyber systems, so digital systems to optimize the production, and now industry 5.0 dealt balancing industrial productivity with impact on people and planet. So people and planet. So there will be a customization, there will be a relationship between the people and the planet via industry 5.0. So that's why there are various kinds of the industrial waves with various industrial revolution. There are three essential facts, because we need to believe three essential facts. Industry 5.0 aimed at supporting, not preceding humans. So it does not mean that it overcome the human decision. It can able to mimic the human decision. Okay, but with minimum time, in order to increase productivity in a mass level, but it is not superseding. And the second one, it is a reality. Okay, it is a reality, it is a fact everyone should believe. And the next fact is that finding the optimal balance of efficiency and productivity. We all know, we know, suppose if we wanted to increase our productivity, there should be a trading off between the efficiency and the productivity. We all know we cannot expect 200% efficiency throughout the mass production. But whereas it aims, industry 5.0 is aiming to provide an optimal balancing between efficiency and productivity. So it tries to achieve 200% efficiency throughout the production. And the third one, the progress of Industry 5.0 is unavoidable. There is a need. We cannot stop the industrial revolution. So that's why from the Industry 4.0, we are still talking about Industrial 4.0, but whereas Industrial 5.0 has already reached into the market. So the interdependence of man and machine using cognitive computing and human intelligence is applicable in the Industry 5.0. So there will be mass customization and personalization as per the human demand. So 2020, now we are in 2024. So almost Industry 5.0 reached everyone's market. So what is the impact? Have you all faced the impact? Have you all realized the impact of Industry 5.0? So yes, of course. So products realized in line with Industry 5.0 and industrial upcycling proposition conforms to many areas. First one, services and business models and the profitability of business and reliability and a continuous increase of efficient productivity and IT security and machine and human security, product cycle increase, and industry value chain and environmental impact decreases, and workers' education, skills, and involvement increase, and socio-economic factors. Yes, based upon the service and as per the demand, various kinds of the business models to be developed, and which of course there should be assurance of profitability. Then only every kind of the business is ready to utilize the Industry 5.0, because the initial investment for Industry 5.0 is somewhat huge. But once we installed, there is an assured mass productivity, automatically the profit can be increased. And the third one, we need to provide the reliability. Everyone should be reliable. They have to use the Industry 5.0 with 100% hope. Then only there can be an increasing usage of the Industry 5.0 in the market. And then there should be security, because it uses computerized algorithms. So nowadays there will be industrial hacking, everything and all. It is not possible to assure security. But whereas Industry 5.0, then there will be an ensured cyber security among cyber physical systems. And the next one, machine and human safety, because there will be smart sensors. All the sensors are smart sensors. So we all know the difference between conventional sensor and the smart sensors. The smart sensors can do automatic error diagnosis, and they can diagnose the failure. Once there is an failure diagnosed, immediately the problem has been resolved. So there should be ensured safety among the sensors, because of the smart sensors which have been integrated or interconnected and formed a network. Then there is an assured safety among the machine and man. And the product life cycle increase. So because of the smart sensor, the life cycle of the interconnected network is increased one. So product we can able to do mass production in an increasing way. It is no need to shut down the process, and we have to scale up, or we have to expand, or we have to attach, or we have to detach certain modules. Everything is possible. And it does not affect the environmental conditions. There won't be any environmental changes which affects the Industry 5.0, or which affects the modularity of the Industry 5.0. That is also very good thing. And there is no bad impact about the Industry 5.0 due to environmental changes. And then only thing is, workers should be aware of the usage of the Industry 5.0. So there should be an assured education. So workers has to be educated in what way we have to choose the smart sensors, in what way we need to get the data, or in what way the data has been acquired or collected, and further it needs to be analyzed. What kind of decision making, once the decision have been provided by autonomous condition, whether it is feasible, everything should be done somewhat with a human decision. So that kind of thing we need to assure. So workers education and workers skill and workers involvement definitely be increased with the help of industry 5.0. And there will be an increased improvement of the socio-economic factors. So industry 5.0 benefits. So takes over past improvements since the first industrial revolution have generated more effective process. See, the knob is almost uh, tuned to high level from the low level to higher level, and there will be an effective process. There will be a mass production with the optimized cost. So the business models which use Industry 5.0 optimized resources, least resources in order to obtain highest profit and highest level of perfection to date, since man and machine work together, because cognitive computing played a major role. Humans intelligence played a major role in order to operate the man, in order to have the human smart network. So it is assured best financial decisions for a company, that is with cost optimization. So starting from 1.0, now we are at 5.0. Hopefully we can go with another version soon. What is required in industry 5.0? Trained personnel, that is only important thing, because the selection of the smart sensors, connection placement and connection interconnection of the smart sensors, and the data acquisition and the data analysis, big data analytics, everything can be done by a personnel who is an engineer sitting in a control room. So that is called trained personnel. We can call chief robotics officer, because he can able to provide a command to operate the robots. So the right technology is cobotos, collaborative robots. So it is very important to have the collaborative robots like cobotos in the industry 5.0 version. And all with industry, starting from industry 1.0 to industry 5.0, the ultimate objective is factory automation. So factory automation is more recently coined phrase that is mentioned to describe the process of incorporating automation manufacturing process of end products. So it is an industrial automation which is having the interconnection of various factory equipments in order to improve the efficiency as well as cost and then reliability of the various process control systems. This in turn leads to lower cost, improved quality, and increased facility, less environmental impact. So here the one picture shows the automation by using robotic arms. The two, especially in car manufacturing. So see, very few numbers of the manual workers, labors are showing in this picture. So other than some three labors, all are robots. So there are undisturbed assembly of the car with various parts by various robots. So once the command has been given in the industry 5.0 by cobotos, then automation has been run. Finally, the full Sorry for the interruption. So almost I reached the last slide. So hope when you go for any industrial plant like steel plant or a cement plant or some
Ma'am?
power station, everything and all, we can see various kind of the panels with larger bulkier solid state relays like this picture. But nowadays, if you go today in today's scenario, if you go for any kind of industry, you cannot witness this kind of picture, because everything was replaced completely with computerized screen. There will be larger computer panels. Then the person can sit in his room and he can able to monitor and he can able to control the entire plant with the help of the computing facility, and nowadays with the cognitive facility. Okay, and one thing I would like to mention as a power system approach, the main important thing is the energy optimization. Because even though we are utilizing many number of the industrial sensors which has been interconnected, all these sensors are smart sensors. We can able to build a smart factory. So with the smart factory, the major parameter we can assure is energy optimization. So power saving is mainly possible with the industry 5.0. So starting from industry 1.0, now we are standing at the point of industry 5.0. So with lots of potential capabilities. So once the potential capabilities are in our hands, so it is our responsibility to utilize. Why not we discard? Why not we hesitate? So definitely we need to utilize. We are the people to migrate with industry 5.0, and the industry 5.0 should be emerged with almost all kinds of processing industries or manufacturing industries or any power related processing and all. Thank you all. Thank you. Now it's a time to answer. If you are having any questions, you can ask me, please.
Dear participants, you can unmute and post the question.
I will provide the PPT. You can share with all the participants, sir. No issues.
Sure, ma'am. Sure, ma'am.
Okay.
Ma'am, if there is no queries, means we can complete, wind up, ma'am.
Okay, okay, sir. So once
just a
again,
minute.
I would like to.
Yeah, ma'am. Before concluding, now I call upon Kalpana to give the vote of thanks.
Yes, sir. As we draw this event to a close, it is my privilege to extend a heartfelt vote of thanks to our esteemed resource person, Dr. S. Vijay Chitra, for sharing her invaluable knowledge with us today. Ma'am, your insights into technologies and your inspiring journey have left us all deeply enriched and motivated. I also wish to express my gratitude to our institution for making this event possible and for ensuring its seamless execution. Special thanks to all the faculty members and participants for their enthusiastic presence and engagement throughout the session. Your contributions have added value to this program. Let us all take the learnings from today's session and strive for excellence in our respective fields. Thank you all.
Okay, thank you. I would like to apologize for the interruptions carried out between my presentation. So it may be due to the network issues. Sorry for the interruption. So once again, I would like to thank the organizers for having given me the wonderful opportunity to be a part of Atal FTP program. Thank you. Thank you all. Thank you participants also. Thank you.
Thank you, ma'am. Thank you. Dear all, kindly wait for next session. By 7:30, the resource person will be joining. So please kindly wait in the same link.
Climate Technologies has also commissioned two large-scale power plants, each with a capacity of 5 megawatt, generating an impression 2 crore units of electricity per year. Looking ahead, they aim to commission an additional 15 megawatt by March 2025, further reinforcing their commitment to renewable energy. In Mr. Vinod John's own words, for a developing country, there is a need for a transformation to ensure the basic needs of the citizen are met: shelter, water, and power. Wind and solar energy offer eco-friendly and green solution to meet these challenges. His vision and expertise make him a thought leader in renewable energy, and we are truly privileged to have him here with us today. Over to you, sir.
In progress.
Unmute போனது
Sir?
Sir, can you hear me now, sir?
Yeah, it's now audible, sir.
Sorry, sir, I'm really sorry.
No issues, sir. No issues. Sometimes it's a situation. It might happen. No issues.
Danger, limit. Full comfort. Lipo, fundamental fresh. Watch Pushpa 2.
Sir, is it okay now?
Yes, sir, it's fine.
Yes, yes. Sorry, sir.
No issues. No issues, sir. Please. Yeah, there is nothing issues. In online,
Yeah.
it will be happening. It is a situation we have to accept it.
Yeah, yes, yes.
No problem, sir. You please start the session, sir.
Yes, yes. Yeah, good evening, everyone. Thank you for having me here today. Thank you for your patience. So I would like to extend my gratitude to all your EEE HOD and all the faculties organizing this session and inviting me to speak. Yeah, as introduction given for me. See, my name is Vinojan. I am a renewable engineer, having a 12 years of experience in the renewable energy industries, running a company called Climate Technologies, where we are closely working with sustainable power systems and system integration as well. So today I'm going to, as the topic given by your team. So today I'm going to talk about next generation smart grids for sustainable power system, the path from industry 4.0 to 5.0. So let me introduce about the smart grids. Today, the need of the hour is smart grid, because you know the net zero implementation and carbon footprints are happening across the globe, where we are in a situation to have a smart grids and sustainable power system, to have a reliability, efficiency, energy system. And if you look at the smart grid, there are four type of four-way people are working on. First one is a two-way communication, where real-time data exchange happening between utilities and consumers. And second thing is automation, where the sensor, control system, intelligent devices, IoT to optimize the operation. And third one is integration of renewable energy, where the renewable energy supports the incorporation of solar, wind, and other renewable energy sources. And now the India is keen to working on integration of renewable energy, and the Solar Energy Corporation of India is working on hybrid system, where they are working on RTC model, round the clock model, where they are trying to enable our transmission system 24/7 with the renewable energy, which is quite impossible as per the current scenario, but we are way ahead on the smart grid. But still, people are taking an initiative, small steps towards a smart grid integration is happening across the India, and some pilot projects are happening in Gujarat. So hopefully we can reach these targets by 2050. We will be able to achieve this net zero target along with the European countries. And the fourth one is a consumer empowerment, where consumer empowerment facilitates demand side management and informed energy usage by consumers. So the today difficulty with the grid electricity network is that we are not able to get the data of actually we have a data for industrial people, but we don't have much data on how the consumption, what is a power quality for the small scale, like small scale industries, LT, low tension connection. We have a data, much data on HT side, but we don't have demand side management on low tension side. So the government is taking an initiative on such initiative to encourage the smart grids system in India. And if you look at the evolution point of view of smart grid, early 20th century, we have limited ability to monitor or control grid operation real-time data. But today the scenario is totally different. We have an entire control over the real-time data. We have both the end from generator side and consumer end, both the end. We are able to get the real-time data, which is helping to analyze the data and motivating industry to have a decentralized energy sources like solar combining with the battery or solar combining with wind. So these are all happening. So today we are developing a 50 megawatt solar park in Tirunelveli, where we are trying to integrate a battery energy storage system for our two clients. So which will enable their 100% reliable on renewable energy goal. So the two companies having a client from Europe, so they are looking at carbon footprint model from their supplier. So this supplier from Tirupur and Coimbatore, they are going to have 100% renewable energy based system for their production unit. So such thing happening, but as a whole scenario, as a whole grid or as a whole network in Tamil Nadu, we have to improve our networking system, and we have to have a policy regulatory model of working for the sustainable power system across our electricity network. As we look at transition from industry 4.0 to 5.0, where you all of you know that the 4.0 is looking at only the IoT based or AI based model, where the 5.0 is customers human centric, where human is taking control over the AI tools to have a better optimized and more reliable system in the future. So what is happening in 4.0 and smart grid is the integration of IoT, AI, big data and automation is happening, and these things are impacting to get a advanced metering infrastructure, where today we are in a position to have a 0.2 class metering set for the generator as well as the consumer, and we have a better control over real-time monitoring, where the state load SLDC, state load dispatch center, is having a very well monitoring and control mechanism in Tamil Nadu, where the generator and the consumer both has to have a detailed metering, online metering, where every data will be monitored, and if any abnormal generation or any abnormality finding in the grid, they'll be giving alarm from their SLDC immediately to the EDC, Energy Dispatch Center. So they have a good control over the real-time data. And today in India, we could say in India, grid reliability and efficiency is very poor in terms of transmission, in terms of distribution. So these smart grids are really going to helpful in grid reliability and efficiency improvement. And if you look at the challenges in industry, the main challenge, people are thinking about cyber security risk, where the data can be stolen or any kind of controlling, because this entire grid is operated by the centralized load dispatch center. If any data from the load dispatch center or system studies, if any data stolen, then it will be in a great risk for the national grid. And again, the second thing is that high initial investment. To update the grid or network, you need to have a lot of time as well, the investment also, because today if you have a study of our Indian grid, unlike Tamil Nadu, the rural part of many states having very poor grid lines, they don't have proper voltage level. Most of the time their voltage is less than 120 volt. So in such pathetic situation, to update their grid, we need to have a lot of initial investment. So that is the other thing. And integration of renewable energy sources, where people are working with the other countries to integrate renewable energy sources without interrupting our conventional system. So that is a main challenge actually. If you look at the point of view of load scheduling, the department people is struggling to have a proper load scheduling during the renewable energy generation. For an example, if you look at our Tamil Nadu scenario, we are the largest wind energy supplier in the country. Next to us, Gujarat is there, but we are the largest supplier in terms of power, renewable energy, wind energy, where during the wind time, this conventional energy having a great challenge to accommodate this load on a time, because the scheduling is a big issue here. We are not able to schedule properly. So for that only, now the government is taking an initiative on DSM, demand deviation settlement mechanism, where 24 hours are divided by 4 slots. Each hour is divided by 4 slots, 15-minute slot. Totally, you will have 96 slots to control over the generation as well the consumption. So this will be helping grid integration in a smarter way. And complex data management. If you look at the data management side, it will be very real. It will be very complex in taking the data from the consumer's end as well, generator end, because you need to have, see, for an example, I'm exporting power from the remote area to the company which is located in urban area. So the each energy dispatch center is different, and each of their data collection is different. Their timeline, everything is is different. So it is very complex scenario in terms of collecting a data in a two different energy dispatch center. So these are all to be addressed by our grid policy meet last year happening. So the MNRE and along with the electrical chief electrical department is working on developing a model for collecting a better data from the source of generation. And the vision of industry 5.0, the key feature is human-centric innovation, where the automation is controlled by the human. So whatever the IoT or AI tools developed model can be collaborated with the human mission and missions to have an optimistic model. And the vision is mainly focusing on sustainability at the core, because if you look at the any kind of G20 or any Paris agreement, whatever you go through, the European country, they are mostly investing on sustainable future. So their main, if you look at Denmark, their major, their major investment is happening at sustainable energy rather than defense. So this is the vital role taking place in every country. So definitely the renewable energy integration will happen in future with a better manner to avoid conventional energy systems. And one more interesting part is that self-healing grids and advanced analytics. So there are few models where people are working on self-healing grids, where the harmonics or any sort of uncertainties can be healing by its own way of controlling the static SVG generators, static wire generators, by implementing static wire generators, supercapacitors, or fourth quadrant relay, whatever the future systems are going to implement for self-gridding healing grids. And key features of next generation smart grid is, the main thing is decentralized energy system. So this is our main focus. We as a climate technology, we are spending our more time on decentralized energy systems. For a case study, I would like to talk about the company which is located in Krishnagiri, where they are taking pulp from the mango. Their industry operation is happening only on 2 months, probably April and May, during the mango season. So we have taken this unit and we have worked a model through which we are planning for a decentralized energy system. So we have arrived at a solution through which we are going to have a 2 months solar generation. We are going to take away their dependent on government grid. We will be removing their government grid, because as you know, for having a government TNEB grid, you need to pay fixed charges, especially for high tension consumers. Their per kVA fixed charges is around 592. So for an example, the company is having 300 kVA load, they have to pay hardly 1.8 lakhs every month. Whether they are using or not, they have to pay fixed charges around 1.5 to 2 lakhs. So to avoid that scenario, we are removing their dependency on our government grid, and we are going to have a smart grid over there, in which we will be implementing solar with battery energy storage system. So our idea in that pulp industry is we will be having a roof, solar on their roof, and we will be having container type of energy storage system through which we will supply their energy demand during the season time. After the season, we will be storing energy from the grid and we will be supplying to the rural area. So this is the model we are working on. So we are speaking with the team where they have to support on the rural electrification. So the policy has to be changed. So we are taking a model as a one village, and we are planning to supply rest of the 10 months through solar energy to the rural village. Because see, if you consider we are planning for battery energy storage system 2000 kilowatt hour in a day. So 2000 kilowatt hour energy system can be supplied more than 200 homes per day. So back in mind, having a idea in that mind, so we are working with the team to have a by having a village adoption to have a renewable energy supply throughout the day and night without any interruption and without any dependency on TNEB grid. And second thing, there are few other new models also coming, features also added up on smart grid. The interesting thing is blockchain for secure energy transaction, like cryptocurrency. There are some models Germany is working on, and they have succeed also. I think I haven't gone through their case study, but they are working on blockchain, and it is under prototype. They have a few studies on blockchain secure energy transaction, and again the predictive maintenance and self-healing networks is a key feature for next generation smart grid. And the another thing is that benefits of next generation smart grid. So as I told you, the people are working on net zero target. So environmental benefits are huge. If you are going in a smart grid, you don't need to run a cable from across the country. You can have a microgrids and have a renewable energy system to generate a energy at a source level. And the carbon we can reduce carbon emission by having a smart grid, and the economic benefits for a long run, it's really working, because if you by adopting a smart grid, the government can reach a good position in economic, because the industry is having a issue on uninterrupted power supply. By having a smart grid, definitely we can achieve uninterrupted power supply, which will definitely boost our economy. And the second thing is that cost efficiency and energy savings. Definitely we can cut down many edges by implementing smart grids, and potential for energy saving also possible by having a smart grids. And pathway from industry 4.0 to 5.0 in smart grid. There are evolution of technologies happening across the globe. So I have recently gone through one article where they are going to have a ball kind of arrangement over the transmission line, which will have a continuous monitoring on the grid, And if any uncertainty or any abnormality find in the grid, it will give an alarm to the load dispatch center. So I think it is in Australia. If possible, I will share the detail later this session. And from automation to collaboration. So as I told you, the industry 5.0 is focusing on human-centric automation. And the second thing is that focus on stakeholder engagement. So and integrating consumer behavior in energy system. Right now, Elon Musk is working on this most of the energy systems in their US, because as per their target, net zero target, they have to have a net zero system by 2030. So the Elon Musk is having a very large perspective in terms of energy systems. He is working with many system integration in terms of renewable energy by adopting many battery systems like sodium ion. His recent research is happening on solid based batteries. So the solid based battery will have a great role in a smart grid system to give a 24/7 uninterrupted power supply. And there are some policies and standards which need to be revised in terms of our Indian standards, because we don't have revised policies for the upcoming industry 5.0 smart grid. So people are working on it, and we are also having a privilege to work with our energy secretary to adopt few technology to stabilize our grid. So we are working closely with our department. So probably we will be in a better position to have a smart grid system in the upcoming years. And supportive regulation for sustainable grids. The MNR is taking an initiative to regulate the regulatory body, pushing hard to have a sustainable grid, and they are giving us a subsidy scheme, and they are monetizing central government and discom distribution companies to have a better sustainable grids. So in Tamil Nadu, government of Tamil Nadu is thinking of giving a transmission line as a private giving to privatize, planning to privatize transmission line, through which they are thinking that their grid can be stable better than the current scenario. And there are few case studies I have gone through. Smart grid implementation in Denmark, where they have taken one city, and they were implementing a smart grid, and they have succeeded also. So they are taking this as a model and working on other cities to adopt smart grid, where they are having for transmission, they are implementing DC grid. So as you know, DC grid having a less there is no harmonic or much interruption in the DC grid. So small micro grids, micro DC grids are implemented across the city to have a better smart grid system. And blockchain based energy trading in Germany. So this is also very interesting part. Today, the energy trading is a big news in every countries, because people are trading in terms of gold. The people are trading in money, gold, and now the movement is happening on energy side also, because energy trading is very essential for the commercial and industrial scale people. So in India, we have a two platform called Indian Energy Exchange and PXIL, Power Exchange India Limited. So these two peoples are trading energy, but unfortunately, Tamil Nadu having a energy trading platform only for conventional energy. They don't have platform on either solar or wind. So they are in future we might have this kind of blockchain based energy trading systems, and this AI driven grid management in USA is very interesting thing, where they manage the entire grid by having a proper monitoring, and based on the input from the generation side and consumer side, this automated AI driven mechanism is taking a control on grid to supply a quality power. So there are challenges and opportunities also. So the main challenge is regulatory hurdles, because unlike other regulatory body, this is a physical system. The regulatory, the policy cannot change overnight. We need to have a proper implementation schedule with a proper mechanism to have a control over the entire network. Then only we can regulate the system. So which is making little time for our Indian grid, but definitely we will have a better manner to have a better position to have a policy for the smart grids. And the technological adoption barrier are also there, because there are people in country still they don't believe in solar energy. They are still thinking of solar energy is not worth for money or not worth for having a better energy system. So even in Tamil Nadu also, as a technical person, I used to go to many companies. People may ask a lot of foolish questions. They don't believe on renewable energy, but still we are convincing them to adopt so renewable energy system. Once they realize that renewable energies bring down their cost, so they'll be in a good position to run the business. For an example, there is a company in Coimbatore where we have done 1 megawatt rooftop installation, and initially we were in talk with that managing director. He is not at all showing interest on solar energy, but we have patiently worked with him, and we have given him a assurance that you will be having a saving on this many things on, and we have put it on a presentation, and we have explained him by adopting solar energy how you are going to gain your production on cotton. So in the final workout, we have shown him that per kg cotton processing, so he is able to save 36 rupees. So he is so happy now, and he is coming up with another 5 megawatt roof ground mounted project in our current project. So this is only on consumer side, where the regulatory side, government officials are not in a position to hear the voice of the normal man or any industrial people. they have their own world to implement the system, which is really affecting the technological adoption. And if you look at the opportunities, you could see we are in a good position to adopting renewable energy today. The country is developing many stage of improvisation in terms of renewable energy adoption, especially government is giving a subsidy for domestic consumers today. And if you look at the newspaper everywhere, you could see the central government is giving a subsidy to the home. So government also taking a lot of initiatives, which is really improving the renewable energy system. And second thing is that the same time we are implementing renewable energy system everywhere, but the tragedy is that we don't have control over harmonics. Since it is a variable generating energy sources, you are not in a control of giving a constant energy. You will be facing a lot of grid instability by adopting renewable energy. So that's the reason having renewable energy along with the monitoring, real-time monitoring as well, the SVG static wire generators to be implemented along with renewable energy to have a better grid stability. And another thing is that innovation in energy storage and distribution. And today in Tamil Nadu, government is taking an initiative on energy storage at each substation level, because today the scenario is like every substation is having a solar energy park, right from Kanyakumari to Chennai. Everywhere you could see every substation is filled with renewable energy. So the thing is that for having a renewable energy, you could generate energy on the daytime. To avoid such scenario, during a daytime, the energy storage can store the energy and it can supply the power on the night hours. Especially government is having a slot for high tension consumers, where the C1 slot is for 6 to 10, morning 6 to 10, and C2 slot covers evening 6 to 10, and C4 slot covers morning 10 to 6, and C5 slots cover night 10 to 6. So these 4 slots, out of these 4 slots, renewable energy can give supply on C4 slot, where today by having a energy storage, government is planning to having a round the clock distribution, adopting energy storage system. So I'm going to conclude on these things, like, so a recap of smart grid innovation. So we are still way ahead to adopting the smart grid innovations. As a industry, we find a gap between industry and institution. So I would like to encourage you to have a research on smart grid integration as a electrical based research facility in an institution like Sri Krishna College. You can definitely work on smart grid integration and along with the industrious people to have a great smart grid integration in future. You can have a collaboration with the government, or you can have a collaboration with the industry to develop a system, because we found a gap between industry and institution, especially in developing a smart grid or integrating a renewable energy system. So as a faculty of electrical engineering, I would rather call you to take a action, and you can spend your time on reading a renewable energy systems and what is happening around us in terms of smart grid integration. And I would like to welcome you all to part of this upcoming smart grid integration in our country. Thank you. So if any question and answer, you can ask me.
Dear participants, if you have any queries, please turn on your mic and raise up your queries with our resource person. Sir? Vinu, sir?
Hello, sir. Yes, sir.
Yes, sir. There is a query which has been posted in chat box, and the query is
Okay.
what are the possible cyber attacks in smart grids? I repeat, what are the possible cyber attacks in smart grids?
Yeah, the main thing is that data stolen activities, sir. See, there is a state load dispatch center for every DISCOM. So the state, the data, everything is controlled by state load dispatch center. So this load dispatch center having a control over entire plants, either generator side or consumer side. So if any data, these are all confidential data, because by stealing this data, you can have an idea of what is happening in the industry, or what they do, how much volume they produce. Everything can be monitored through this data. And second thing is that the grid, I have gone through an article where they, by cyber security issue, the grid was unstable for 24 hours. So this can be avoid by having by only way to avoid this cyber security issue, adopting 5.0.
And sir, there is another question. The question is about net zero implementation. How net zero implementation can be done for a domestic purpose, such as for our residential areas.
Right now, we don't have much strategy for net zero strategy for domestic purpose, sir. We have a working for industrial scale. But in future, see, the net zero is nothing. You are completely relying on renewable energy, or you are having a good energy efficient system either. So both way, having both end, you can have a control over your net zero implementation. So for domestic purpose, as of now, you can better by adopting renewable energy 24/7 without depending on energy, your DISCOM grid. If you are able to operate your system, then you are 100% net zero implementer.
Okay, thank you, sir. Dear participants, if you have any queries, please rise up. Our resource person is ready to answer for your queries. If there is no queries, we can wind up the session. Participants, if you have any queries, please post across the chat box. If it is nothing, we can go for a vote of thanks for our resource persons today. Okay. Okay, thank you so much, sir, for your wonderful session.
Yes, sir. Thank you.
Now
Thank you.
Yes, sir. Now I request our Brinda Sri to give vote of thanks for our session. Brinda Sri, you can deliver the vote of thanks for the session.
Sure, sir. As we conclude this enlightening session, it is my privilege to deliver the vote of thanks. First and foremost, I would like to express my heartfelt gratitude to our resource person, Mr. Vino John S., for taking time out of his busy schedule to share his invaluable knowledge and experience with us. Sir, your insights into the renewable energy sector and your success stories have been truly inspiring. Your words have ignited a sense of responsibility and possibility in all of us. I extend my sincere thanks to our institution for organizing this session and providing a platform to learn from such a distinguished leader. A special thank you to all the faculty members, students, and participants for their active involvement and enthusiasm throughout the event. Your presence has greatly contributed to the success of this session. Let us all carry forward the learnings from today and work towards a sustainable and greener future. Thank you and have a great day ahead. Thank you, sir.
Thank you. Yeah. Thank you, Brinda Sri, for delivering vote of thanks for a resource person. And I thank Vinod John, sir, for delivering your valuable speech on the grid integration automation for our AICT Atal program of third day.
Thank you. Thank you, sir. Thank you,
Yes,
sir.
sir.
Thank you.
Yes, thank you, sir. And dear participants, the feedback form has been shared across the chat box. The chat box will be open up to 10 a.m. tomorrow. So I request all the participants to fill up the feedback link for today's session. Both the sessions will be active till 10 a.m. tomorrow. Thank you. And we'll be meeting up tomorrow sharply by 6 p.m. Thank you all and good night.
Thank you, sir.